These are the frequently asked questions for Algebra 2 for Section 6, 7, Day 2. I'm going to start with number 24 here where it says graph each relation and its inverse. So what we want to do is, of course, graph the original. Then we want to find the inverse and figure out how to graph that. So for 24 we have y equals 3x squared, and that is the parent function that we would graph because that is y equals 8x squared. And of course you see the x squared and we start to envision that parabola. So we're going to use our standard numbers here for graphing a parabola. So negative 2 squared is 4, and 4 times 3 is 12. Negative 1 squared is 1, and 1 times 3 is 3. 0 squared is 0 times 3 is 0. 1 squared is 1 times 3 is 3. 2 squared is 4. 4 times 3 is 12. And we start to see that symmetry in the y values here. So I'm going to graph the ones that will show up on my graph here and just kind of aim for that negative 212. If this were on a test, you know what, I'm going to do this as if it were on a test. I'm going to change my y-axis to go by 2's. Because on a test, you know, it's really important that you're doing things accurately. I'll continue to go by 1's on the x-axis. So negative 2, 12, negative 1, 3, 0, 0, 1, 3, and then 2, 12. All right, so there is my original. That is y equals 3x squared. Now for my inverse, I have to switch the x and the y, and then I have to solve for y. So the first thing I would do is divide by 3, and that'll give me 1/3 x equals y squared. And then I'd have to take the square root of both sides. So it would be plus or minus the square root of 1/3 x equals y. So now I go to make a table for this one, and I realize that I can't use negative values because then I'll be getting complex number solutions with imaginary solutions here, and I don't want that. So the smallest number I'm going to be able to use in this function, my inverse function, is 0, and that of course would give me 0 right back. And then I don't want to put 1 in there because then I'm dealing with the square root of 1. So I'm really hoping to get a nice perfect square that I could use for this. So if I put a 3 in there, 1/3 of 3 is 1, and so the square root of 1, that's going to give me a plus or minus 1. And then I try to think, okay, what would be the next thing for a really nice perfect square? And of course that would be the square root of 4. So you think, all right, well, what would I do with the 1/3 to make sure I get a 4? Well, the 3 would have to cancel with whatever number I have up here and give me the 4. So then you think, well, all right, that'd have to be 12. So I'm going to put a 12 in here, and that 12, once it's in, again, would give me 4. The square root of 4 is 2, so plus or minus 2 for those two. And I maybe didn't even need that last one anyway, but it's just nice to see the different numbers that we get for this. So we're at 0, 0, and then at 3, we're at positive and negative 1. And then out here at 12, looking like so. And this is a pretty obvious one where the original is a function, and the inverse is not going to be because of that plus and minus piece. So those two are now graphed, and boy, that took up some space. So I'm going to have to erase that to go after the next one that I have here for you, which would be number 26. So number 26 is y equals 4x squared minus 2, and the parent function for that is y equals 4x squared. So for that, you just quick make our little table using the standard numbers here, negative 2, negative 1, 0, 1, and 2. Negative 2 squared is 4, 4 times 4 is 16, negative 1 squared is 1, 1 times 4 is 4, 0 squared is 0, 0 times 4 is 0, 1 squared is 1, 1 times 4 is 4, and again we start to see that symmetry, so we realize we don't necessarily need all of that. Now, this one, I am not going to change and go by 2's. I'm just going to go ahead and graph the set of 3 that I have here that are pretty decent. And this is just the shape of my graph because that was the parent function. I have not yet moved that 2 down because remember that is our k value. So our k of -2 means that I need to take this graph and I need to move it 2 units down. So I just take those 3 points that I just finished up graphing and I move those points 2 down. It's as easy as that. All right, so there's my original. And again, what I need to do is find the inverse for that. So I switch the x and the y, and then I solve for y. I would add 2 to both sides, divide both sides by 4, and then I'd have to take the positive and negative square root. And I get that little monster in there. So with this one, I just want to put in enough that I can see where that curve is going to go, where that parabola is going. So let's see here. I think I'm just going to deal with some decimals if I have them. Otherwise, I'm going to spend too much time putting numbers in here to make this work. The first number that we need to use is the one that would make this 0. So what I'm going to do is come over here and just do a little math to get that 0. So we would subtract the 1/2 from both sides. Then we would multiply both sides by 4. And that would be a -2. So if we plop a -2 in here, we'll get -1/2 plus 1/2, which is 0, and the square root of that is 0. And then what I might do is just pick a nice number like 4, because 1/4 times 4 is 1, and then I get 1.5. And then I just grab a calculator and approximate the square root of 1.5. And that's about 1.2. So that'll be plus or minus 1.2. So we are at -2, 0. And then we are at 4. And a little bit more than 1 up and down. And again, that gives me a good feel for what's going on. It in fact, verifies for me that I did this correctly, because again, we need to see that visual of the reflection in the line y equals x, and that is what we see there. So a lot of good review in these problems about how to graph. That's the key. That's the reason these are on here. So in number 27, we think, hey, this is that whole y equals a times x minus h squared plus k, and it is. And in this case, our parent function is just going to be y equals x squared. So that is our -2, 4, -1, 1, 0, 0, 1, 1, and 2, 4. So there's the shape of the graph. And then all I have to do to get it graphed is move it appropriately. So I realize that h is a 1. And when h is 1, that means I need to shift my graph 1 unit to the right. So that's exactly what I do. I shift it 1 unit to the right. There's my original. And now, of course, I need to find the inverse. So if it's y equals the quantity x minus 1 squared, I have to reverse, switch my x and my y. And then I'm going to need to get rid of that squared in order to get to my y. So that means I'm going to have to take the square root right away. And that gives me that little plus or minus piece there. And then I would add 1. And then with this one, I guess if you guys want to go ahead and use your calculator to graph these, I wouldn't be too bothered by that. The problem is I don't want you to forget the negative as well. This is actually what we learn to graph in the next section. So what I really hope you would do would say, okay, the parent function in this pretty obviously is the square root of x, and then I'm going to shift that 1 unit up. You know, if we still stick with that a, h, and k pattern, that's what we're going to do. So I can't use negative numbers. I can use 0, I can use 1, and then I'll use 4 because that's a nice square root. So if I put 0 in, I get plus or minus 0 plus 1. Well, 0 can't be positive or negative, it's neutral, so the answer is going to be 1. If I put a 1 in there, I'm going to get plus or minus 1 plus 1. Well, 1 plus 1 is 2, and negative 1 plus 1 is 0, so 2 outputs for 1. Already we know this is not a function. You put in the 4 and you get 2. Well, that will give you 2 plus 1, which is 3, but then it'll also give you negative 2 plus 1, which is negative 1. So we are at 0, 1, and then we have 1, 2, and 1, 0. And then we have 4 at 3 and at negative 1. And again, we can see that nice symmetry that goes along with this and realize, hey, that inverse is not going to be a function. We knew that anyway looking at it. Whenever you have an even power in your original, you're going to have to take the square root, the fourth root, the sixth root, and even root, and that always indicates that we are going to have ourselves a plus and minus as part of the process. Number 28 is y equals, and then we have 2 minus x squared, and that is just really weird. So what I decided to do is make this look like it should look, y equals 8 times x minus h squared plus k. But to do that, I've got to reverse this, like so. And then I think, I don't like that negative there. Can I just take that out? Well, yes and no. I mean, we're going to pull a negative 1 out of that. We're going to factor that out and make this x minus 2 squared. And then I realize, well, negative 1 squared is just 1. So would that give me the exact same thing as x minus 2 squared? Well, you could go ahead and put some numbers in and see. If we try negative x plus 2 squared, the question is that going to give us the same thing as x minus 2 squared? So, we put some numbers in and we see. Let's try negative 2, negative 1, 0, 1, and 2. Negative 2 with a negative in front of it will be 2, and then 2 plus 2 is 4, and 4 squared is 16. If we put a negative 1 in here, there's already a negative, so that'll be 1 plus 2, which is 3 squared, which is 9. Put a 0 in there, 0 plus 2, 2 squared is 4. Put a 1 in there, negative 1 plus 2 is 1 squared, which is going to give you 1. And then negative 2 plus 2 squared gives you 0, and we'll be able to see the symmetry from there. So the question is, does that do the same thing as this x minus 2 squared? So let's put them in, and let's see. Well, this would give us negative 2, and negative 2 minus 2 is negative 4, and negative 4 squared is 16. Aha! Negative 1 minus 2 is negative 3, negative 3 squared is 9. 0 minus 2, negative 2 squared, 4. 1 minus 2 is negative 1, negative 1 squared is 1, and then 2 minus 2 is 0, and that's going to give you 0. So you see it does work. We can factor that out. So we still have that A, H, and K process going if we can factor to make it look like we want it to. We can force it into that situation. So let's see what we've got here. We've got a negative 1 and a 9, 0, 4. And then we have a 1, 1 and a 2, 0. And then, of course, you realize if you put a 1 in there, negative 1 in this position, a positive 1, 1 minus 2 would be negative 1, and negative 1 squared is back to 1. So that 0 that we have on the x-axis, so a 0 of y, is kind of that turning point for us. So here is the original, which is basically just y equals x squared, but h is 2, so it's moved 2 units to the right. So whether or not you use the table or you factor it, you'll get in the same place. And again, we have to go after our inverse function yet. So reverse the x and the y, take the square root right away. And then it's up to you how you do the next one. Some people like to add the y to both sides so they're not trying to divide all this by a negative, and that just freaks some people out. But let's go ahead and subtract 2 from both sides and divide everything by a negative 1. Well, if I have a plus and a minus in front of the square root of x and I divide them by negative 1, it'll become a negative and a plus. So see, it really doesn't do anything to that plus and minus in front, but it does change that negative 2 in the back to plus 2. So I start thinking about that whole square root thing that I had going on in the last problem, and I realized the numbers I used for that were 0, 0, 1, 1, 4, 2. And I see here that I'm supposed to add 2 to that. And I think, well, normally what that would do to any other graph is it would move it 2 units up. And then I'd use symmetry to figure out where the other points are at. And if you graph that with your calculator, you will see that's what's going on there. The square root of x plus 2 is just the graph of the square root of x, and then we're going to move that 2 units up. So, number 29 looks pretty nasty. Let's see what we can do with number 29 to make that look nicer. So we have our whole AH and K business going on. All right, so what I really need first is I need that x in front. Then what I need to do is get rid of that negative 2, so I'm going to have to factor that out. So I think, all right, factoring is really like dividing stuff. So this is just going to be an x. Then I'm going to need a negative, because a negative and a negative would give me a positive. And 3 divided by 2 is just 3 halves. Now, this negative 2 squared, that's 4. So now my parent function would be y equals 4x squared. And that I can just make a quick table for and get my parent function. So negative 2 squared is 4, times 4 will give me 16. Negative 1 squared is 1, times 4 is 4. 0 will get me 0, 1 is going to get me 4, and 2 is going to get me 16. So this is the shape of my graph. That 4 in the front has made this kind of tall and narrow. And now what I need to do is just move it to the correct location. Well, there's my x minus h squared plus k. So h is 3 halves. That means I need to move it to the right 1 1/2. And my k value is negative 1. That means I need to move it 1 down. So right 1 1/2, 1 down. Right 1 1/2, 1 down. Right 1 1/2 and 1 down. So there's my tall and skinny function. And now what I need is the inverse function. So I'm going to go ahead and switch the x and the y. And then, whoops, I'll put an equals there instead of just my subtraction. I'm going to move the 1 over. And now I have to take the square root to get rid of that squared piece. And that, of course, will be plus or minus. The square root of x plus 1 will equal 3 minus 2y. I will have to subtract 3 from both sides. And then divide everything by a negative 2. Now, that one is pretty nasty, but it's AH and K. That's what it is. So if we can get a table here for the a, h, and k piece, which would just be y equals a square roots of x, then we'll know the shape and we can just move it h and k. So y equals, well, let's see. Let's go ahead and put this 1/2 x here, square root of x, so everybody can see that piece. And then just use our staples here that we would take the square root of, starting with 0. Square root of 0 is 0 times 1/2 is 0. And then we'd have the square root of 4 is 2, and that would give us 1. And don't forget we had our little plus or minus piece here. We'll think about that later though as we go through and graph it. It just uses symmetry, so usually I won't even bother putting that down. And then 9, the square root of 9 is 3, and that'll give me 3/2, which is 1/2. So that's the shape of my graph. 0, 0, 4, plus or minus 1, and then 9, 1/2 in both directions. But that's not the final product because my h value up here was a -1. That means I need to move this to the left. And my k value was 3/2, which means it's going up 1/2. So the green that I have up there, I'm actually going to switch colors here so I don't get lost in the translation here. I need to move 1 to the left and 1/2 up. So 1 to the left, 1/2 up. 1 to the left, 1/2 up. And I can see my smartboard alignment is off again. 1 to the left and 1/2 up. And there it is. And again, it makes perfect sense from what we know. Now that's probably extreme overkill. Because generally we let you use your graphing calculators at this point for graphing those pieces. All right, then for each function, find the inverse and the domain and range of the function and its inverse, and determine whether the inverse is a function. 31. We have f of x equals the square root of x minus 5. Well, let's just follow the directions. We're going to find the inverse. So right now it's y equals the square root of x minus 5. We switch the x and the y, and we solve for y. That means I'm going to have to square both sides. So x squared equals y minus 5, and then I'll have to add 5 to both sides. And I get y equals x squared plus 5. Now, way back up here at the beginning, it says find the inverse and the domain and range of the function and its inverse. So here's the original. And I notice right away I have this square root business going on. And that means I need those to be positive. My radicand needs to be positive. Well, if I put 0 in there, I'm going to be taking the square root of -5, and that's imaginary, so I can't use that. So I think, well, what's the first number I could use? Well, it's 5, because 5 minus 5 would be 0. So x is going to need to be greater than or equal to 5 so that we can get a 0 out of that. And if x is greater than or equal to 5, we would put the 5 in, and the smallest number that's going to pop out is going to be 0, because 5 minus 5 is 0, and the square root of 0 is 0. So now the good news is, I don't really have to do any thinking at all about the domain and the range for my inverse function, because remember, inverse functions are all about reversing the x's and the y's. So I go up to the range, and I see that that was y is greater than or equal to 0, so I know my domain is going to be x is greater than or equal to 0. And I go to my domain in the first function and see x was greater than or equal to 5, so I know y is going to be greater than or equal to 5. So, last thing to do, a lot here, find the inverse, domain and range of the original and the inverse, determine whether the inverse is a function. Well, when we found the function, at no time did we put a plus or minus in there. So if we put one number into our inverse function, we will get one number out. So because of the domain restrictions on all of this, yes, it is a function. It works. So there it is. In fact, the original, like I said, with the domain restrictions that they give us, the original will be a function and the inverse is a function. All right, next one on my list here is 33. Number 33. We have f of x equals the square root of negative 2x plus 3. So I want the inverse. I'm going to go ahead and switch the x and the y. Remember, f of x, g of x, that's just function notation for y. And I'm going to have to square both sides right away because I can't gain access to that y unless I do. So I square both sides, and I have x squared equals negative 2y plus 3. I would have to subtract 3 from both sides, and then I would have to go ahead and divide everything by negative 2. Alright, so there it is. Now we go back and do domain and range. So here was the original. And if we're careful about this one, then we don't have to do any new math for the domain and the range for the inverse. So I know that negative 2x plus 3, the lowest that can be is 0, so that's my cutoff. So I'd have to subtract 3 from both sides and divide by negative 2. And that would give me x equals 3 halves. So x needs to be greater than or equal to 3 halves. All right, next up, we try to figure out what exactly is going to happen if we put that 3 halves in there. And if that's going to be greater than or equal to 3 halves, does that take us the right direction? So we put this in, and the reason I bring this up is because the front number here, that leading coefficient, is a negative. And usually when we do this, we don't have a negative in the front. So let's just think about the fact if we put a 5 in there. That would be negative 10 plus 3. That's negative 7. That's going the wrong way. So for one of the first times as we've gone through this, we can't use greater than or equal to because of that negative in front of that x term. And you think about it for a second, it makes sense. I mean, if you put 0 in there, negative 2 times 0 is 0, 0 plus 3 is 3. It's not a fantastic square root, but we can do it, you know, we can still get that. So then we realize, all right, so the range this time is going to be y, and it's going to be 0. But do we have to worry about flipping that one? Well, if you take a look at it, we put our 3 halves in there and we get 0. And then we said we're going to put lower numbers than that in there. So we still are going to have y values that are greater than or equal to 0. It's just our domain that has to be different to make this happen. That has to be our less than or equal to. Now, like I said, we spent some time on that one. Then we don't have to spend quite so much time on the domain and the range for the inverse. So for this one, remember, you switch domain and range with the original function. So if this was y is greater than or equal to 0, this one will be x is greater than or equal to 0. And then if the domain is x is less than or equal to 3 halves, the range will be y is less than or equal to 3 halves. So, boy, that's a good problem there. That takes a lot of thinking as you go through there. Now, is the inverse a function? Well, look at what we did for the inverse. We didn't have to take any square roots, fourth roots, anything like that, and there was no plus or minus. So, yes, the inverse is a function. So, excellent problem. We really have to think about the domain and range on that one in order to get things to work out. All right, now that should make all the rest of these seem easy. So let me go back and look at 2x squared plus 2. So y equals 2x squared plus 2. We want to find the inverse. We're going to switch the x and the y. We're going to subtract the 2. We're going to divide by 2. And we're going to take the square root. And that, of course, introduces that plus or minus. So right away, we know that our inverse is not going to be a function. All right, so back up. Domain and range on the original. There are no square roots, no fourth roots, no sixth roots, no even roots. There's no division, so the domain and range are all real numbers for number 34. Domain and range are all real numbers. Now, you think about that all real numbers piece, but you realize there is a cutoff for the range. So here's another one where we have to think a little bit. Because this is 2x squared plus 2, the lowest the y is ever going to go is 2. So our y's will be greater than or equal to 2. So when I was stressing in class how the visual is so important, that's a big part of what helps us with our domain and range. You know, we can't just say, okay, if we don't see any even roots, if we don't see any division, everything's going to be good. Because in this case, we have a parabola. The lowest it will ever go is the point 0, 2. And we have to keep track of that. So our inverse domain and range. Remember, we have to flip-flop the domain and range of the original. So x greater than or equal to 2. And you take a look at this, and that makes perfect sense, because if we put a 2 in there, we're going to get 0. And then our range is going to be all reals. And of course, as I talked about before, nope, not a function. We have that plus or minus piece in there that's going to keep us from being able to do what we need. 36. We've got the formula for converting Celsius to Fahrenheit, and A says find the inverse of the formula. Now, remember, we talked in class about how you do not switch the x and the y. You do not switch the variables when you're working with a word problem. You just solve for the one that's not already solved for. So in this case, we want to get this c all by itself. So we would subtract 32 from both sides, and then we would multiply both sides by 5/9. And actually, if you're going to use that formula for anything, I probably would not distribute the 5/9. You're going to introduce more fractions into all of this. So we might just want to leave it like that. And then it says, is the inverse a function? Well, this was a line, and yeah, for lines, it's going to be a function. So yes, a function. All right, B. Use the inverse to find the Celsius temperature that corresponds to 25 degrees Fahrenheit. That's what I wanted to see him do, have us use this for something. So what we're supposed to do is use our little formula with 25 in there to get the Celsius temperature. So let's see what we can do here. We need to take 5/9 times -7. And it is approximately -4 degrees, -3.9. Let me peek here and see which decimal the book went to. They did go to tenths, so we'll go ahead and go to tenths. Approximately -3.9 degrees Celsius. So that's the nice thing about it, especially if you're in science class and you have a lot of conversions that you have to do. That's the nice thing about converting that formula first. That was part B. Number 37, volume of a sphere. A is find the inverse of the formula. Again, we do not switch the variables in word problems. So I'm going to go ahead and multiply both sides by 3/4. These little buggers are going to cancel right out. Then I need to divide both sides by pi. Well, I've got a fraction over here already. So instead of dividing by pi, on this side, I'm going to do the same thing. It's equivalent to multiplying by 1/pi. So that's going to give me 3v over 4 pi. And last but not least, I need that little cubed root. The only good thing about that is I don't need the plus or minus. So cubed root of 3b over 4 pi equals r. There it is. B says use that inverse to find the radius of a sphere that has a volume of 35,000 cubic feet. All right, so we need the cube root of 3 times 35,000 divided by 4 pi. Okay, I'm going to do this in steps. So I'm going to follow the order of operations and take 3 times the 35,000. And that is 105,000. I'm going to divide that by 4 times pi. And that is 8,355.634, blah, blah, blah. And then use that math number 4 button, which is cube root, with that answer. And it is approximately 20.3. And I better look up, but I believe all of this was in feet. Yep, cubic feet. So this is feet when we're looking for the radius there. All right, now on to the next one. Oh, this one, I love this. For exercises 38 to 41, f of x equals 10x minus 10. Find each value. And 38, if you're doing a lot of math for this one, oh, you forgot the important, very important piece here. If this is the original, and we do composition with the inverse and the original, we will just get x. That is our formula. So if we put a 10 in for x, our answer is 10. And we're done. It didn't say find the inverse, then use composition to verify that it is the inverse. It just said find this. Well, then that's what I know it is, because when you do composition with the original and the inverse, no matter which direction, if you've done it correctly, you should just get x. Then, number 44, find the inverse is the inverse of function. Not that I haven't done enough of these already, but never hurts to do some more. So x equals 2y squared over 5 plus 1. So I'm going to go ahead and subtract 1 from both sides. And then the next piece you could do in 1 step or in 2. I'm going to go ahead and do this in 1 step and multiply by 5 halves on both sides. So 5 halves x minus 5 halves equals y squared. And finally, the square root, which means plus or minus. So plus or minus the square root of 5 halves x minus 5 halves equals y. Is the inverse a function? No way. Got the little plus or minus action going on there. No, the inverse is not a function. Number 46. Y equals 3x squared over 4. Switch the x and the y. And then again, 1 or 2 steps here. I'm going to go ahead and do it in 1 and multiply both sides by 4/3. So 4x over 3 equals y squared, or 4/3 x. It doesn't make any difference. We're going to need the square root. So plus or minus square root of 4/3 x equals y. And as soon as you get that plus or minus piece, you know the answer to is the inverse a function is no. It is not. It is not. All right. Number 47. Replace that f of x with y. Switch the x and the y. Subtract 3 from both sides. And then we're going to square both sides so that we have access to that y. So over here we have, oh, you might want to leave it that way. I'm going to go ahead and multiply it out. And And the reason I'm doing that is because I see I have a 1 there, so I'll be moving it back over anyway. So I'm going to add 1 to both sides. Uh-oh, smartboard. It's a little slow. And then divide everything by 2. And there it is. Is the inverse a function? Yes. We don't have any plus or minus pieces going on with number 47 there. So finally we have an inverse that is a function when we go through there. All right. Did I have any more? I did. 52. For each function, find the inverse and the domain and range of the function and its inverse. Determine whether the inverse is a function. 52. Y equals the square root of x plus 3. Switch the x and the y. Subtract the 3. And square both sides. Now on that one, we'd probably be pretty safe just leaving that as y equals x minus 3, the quantity squared. And I'm going to put some function notation. I didn't do that with any of the other ones, but I'm definitely going to put that here this time. So, domain and range of the function, well, up here. I have a square root of x, so x has to be greater than or equal to 0. And if I put a 0 in there, 0 plus 3 will be 3. And if I keep putting higher numbers in, then I'm just going to keep getting higher values for my y variable here. So y is greater than or equal to 3. So I go down to my inverse. And for my inverse, remember the domain and the range. Flip-flop. So my domain will be x is greater than or equal to 3. And my range will be y is greater than or equal to 0. And then definitely we'll have an inverse that is a function this time because we don't have that little plus or minus piece as we're going through there. All right, let me get to 53. 53 is y equals the square root of negative x plus 3. Reverse, switch that x and the y. Now, to gain access to the y, I'm going to have to square this right away. And then I will subtract 3 and divide by a negative 1. Like so. And again, I'll go ahead and put the function notation here. All right, so back to domain and range. And I notice I have that negative x in front, so let's kind of think through this like we did the other one. So normally we'd say, hey, our cutoff is going to be 3. And we put greater than or equal to 3. But there's a negative in front of there. So if I put a 4 in there, then it's going to be negative 4 plus 3, and that's imaginary. So I can't go greater than or equal to. It has to be less than or equal to. And if I put 3 and less than 3 in there, well, the smallest number I'm going to get is 0, and it's going to be y is greater than or equal to 0. So it's, again, thinking through what's going on with the graph as you do this. Then, down here is my inverse function. And remember that our domain and range are going to flip-flop for the inverses. So the domain becomes x is greater than or equal to 0, looking at the range. And then our range is y is less than or equal to 3. Those flip-flop. And now as we look at our inverse, there is no plus or minus going on here. There are not 2 outputs. There will only be 1. So yes, the inverse is a function. Alrighty, 56. Smartboard is tired. It wants me to go home. Number 56, y equals 1 over x squared. We're going to reverse those two. Now, the variable I need is in the denominator, and it can't be there. If we're going to solve for that, we have to get it out of the denominator. So easiest thing to do would be just multiply both sides by y squared. And these two y squareds are going to drop right out. And then what I need to do is divide both sides by x and take the square root. And that means plus or minus. And the square root of 1 is just 1. So 1 over the square root of x. My guess is they're not going to have us rationalize the denominator or anything like that at this point. But let me double check. Yeah, they do say to just leave it like that. It's just one of those things. So y equals plus or minus 1 over the square root of x. Now, go back and think domain and range. Okay, so my domain here. Well, I can't use 0. I can use anything else, but I can't use 0. And what will I get if I do that? Well, let's see. If it was 1 over 1, then that's going to be going down to 1. If it's 1 over 1/2 squared, that's going to go to 4. So there is a spot here that this graph is not going to go any farther than. And you might want to graph that original with your graphing calculator so that you can see what's going to happen here. But what happens is it never quite makes it to 0, and it's definitely not going to be below that. So y is greater than or equal to 0 is what we get for the range. And then for our inverse function, we need to reverse the domain and the range of the original. So we will have x is greater than or equal to 0, and y cannot equal 0. And we do have a square root down here in our inverse function with the plus and minus. So this one is no. The inverse is not a function. Whew, that was a lot of them, but I'm done.